So business intelligence seems to be one of the main factors behind corporate interest in the field. Let's talk about business intelligence a little bit. Let's go to here and look at Wikipedia. And business intelligence refers to computer-based technologies used in spotting, digging out, and analyzing business data, such as sales revenue by products or departments, or associated costs and incomes. Business technologies provide historical, current, and predictive views of business operations. Common functions of business intelligence technologies are reporting, online analytical processing, analytics, data mining, business performance management, benchmarking, text mining, and predictive analytics. Okay, and let's read a little bit of a report from Gartner. This is 2009. Gartner reveals 5 business intelligence predictions for 2009 and beyond. Let's see. Organizations will expect IT leaders in charge of business intelligence and performance management initiatives to help transform and significantly improve their businesses. Through 2012, more than 35% of the top 5,000 global companies will regularly fail to make insightful decisions about significant changes in their business and markets. IT leaders in companies with a strong culture of information-based management should create a task force to respond to the changing information and analysis needs of executives. By 2012, business units will control at least 40% of the total budget for, I don't know what that means, for BI. By 2010, I guess that's now, 20% of organizations will have an industry-specific analytic application delivered via software as a service as a standard component of their business information portfolio, and so on. Okay, so let's go on. A major computer manufacturer, disappointed with unexpectedly low sales, finds itself confronted with the question, why aren't consumers buying our laptop? While concrete data, such as the laptop's weight or the price of a competitor's model, are obviously relevant, answering this question requires focusing more on people's personal views of such objective characteristics. So what sort of getting the personal views about these objective characteristics. Moreover, subjective judgments regarding intangible qualities, for example, the design is tacky, or customer service was condescending, or even misperceptions, for example, updated device drivers are not available when such device drivers do in fact exist, must be taken into account as well. Sentiment analysis technologies for extracting it would be difficult. Sentiment analysis technologies for extracting this information would obviously be very valuable. It would be difficult to try to directly survey laptop purchasers who have not bought the company's product. Of course, that would be very difficult. Rather, we could employ a system that A, finds reviews or other expressions of opinion on the web, news groups, individual blogs, and aggregation sites such as e-opinions are likely to be productive sources, and then B, create condensed versions of individual reviews or a digest of overall consensus points. This would save an analyst from having to read potentially dozens or even hundreds of versions of the same complaints. Note that internet sources can vary widely in form, tenor, and even grammaticality, This fact underscores the need for robust techniques, even when only one language, for example English, is considered. Okay, let me just take a break here and show you some interesting things that have been done. Actually, some of our students have done some interesting things, but they're not online right now, unfortunately. They were online. But I'll just show you a few things, other things. So, this is from the New York Times. And what is this? Twitter chatter during the Super Bowl. So this was, I think, last year. I think it was 2009 Super Bowl. And as the Steelers and Cardinals battled on the field, so if you're familiar with American football, Twitter users across the nation pecked out a steady stream of tweets. The map shows the location and frequency of commonly used words in Super Bowl related messages. So you can see, first of all, I suppose that they filtered out so they got only the messages that were related to the Super Bowl, and this was during the actual time that the Super Bowl was being played. And you can see that the score at 6:15 p.m., which was, I guess, the beginning of the game, was 0-0. This is the Steelers, and this is the Cardinals. And at that time, we could see lots of different tweets. People were tweeting, and the top words near Pittsburgh, and that's the Pittsburgh Steelers, was Steelers, and this is like some kind of ranking: 59, Go 31, Cardinals 9, and Cardinals. Where are the Cardinals from? I forget. But anyway, so as we move across here, this map is kind of interactive like this. Top words near Fresno, Cardinals, Steelers 1. Okay, this was all tweets, I guess, and this is Steelers versus Cardinals. We get this kind of picture, and then one of the big things about the Super Bowl is the ads, the commercials. Companies pay like $1 million a minute to have their commercials run on the Super Bowl. So people discuss the ads, and I guess people were talking about various things like Hulu. Maybe you know the Hulu website, and so on. And the player names. These were the names that were being tweeted at the beginning of the game. And emoticons. Now, these turn out to be very important in tweets. This is a very popular way for people to express their sentiments. So if we are going to do sentiment mining on tweets, are going to have to take careful consideration of the emoticons, which actually I've failed to do up to this point, but it's obviously important. So you can see the emoticons here and how they look. Now maybe if we looked at Pittsburgh, which would be somewhere around here, and if we looked maybe when the Steelers were losing, then we might find a change in the emoticons there. And the people saying go. Okay. Now you can play the timeline, and I don't think there's a way to change the speed, but let's see what happens. You can see this kind of effect. And let's see if you talk about all tweets. You can also just move the timeline, and you get this kind of fun, interesting. So now what? The score is 17-7. And this Springsteen, I don't know what that means. Is that Bruce Springsteen? Maybe, yeah, it's Bruce Springsteen. So maybe he was playing at this time. This is halftime. Halftime begins, And you can see that people are tweeting about Springsteen. And what about the ads? So you can see the tweets about the ads as well. I don't know what the ads were at that time, but I guess I just saw Coke there. I don't know. Oh, Monster is probably a job site. Budweiser is a beer, Bridgestone, and so on. Okay, so this is a kind of fun application. By the way, what happens at the end? You saw GoDaddy there. That was one of them. Steelers. I guess the Steelers won, right? And most people are tweeting Steelers. Okay, that's one. Here's another one. So here you can get Twitter sentiment. So I'll type in Android, which is I guess I should type in maybe Google Android. I'll just type in Android. Hopefully that's the Android phone. Okay, so here it is. Sentiment analysis for Android. You can see there's a timeline here. And you can change it to show hourly chart and percent, but I think this is good. And you can look at recent March 2010. And what you have is a mapping of the positive sentiment is green and negative sentiment, which is red. Now the question is, how do we determine what's a positive sentiment in a tweet and what's a negative? That's what we're going to be talking about. But anyway, they have a method for doing this, and your fellow students have done something quite similar to this, and we want to continue with this. You can look at the sentiment by percent. So 45% is negative and 55% is positive. They have this graph as well. And they also show, they show typical tweets. You can choose a date range here, I guess. And damn, really can't decide between Seismic or Twiggy for my new primary Twitter Android app. Both seem great. But Blackberries are so sexy. Do they have Android phones? Tell us anyways. So here, when was this? This was just one day ago. This is April. iPhone app is up and running. Enjoy your iPhone, iPad, and Google Android phone. Tell your friends. I wonder what app that is. I really hope so. The Android marketplace needs to do a better job of spotlighting awesome apps. Okay, we could do the same thing for any other keyword or query. Okay, so that was just a short excursion into the kinds of things that we might be thinking about. Let's go back here. Okay. By tracking public viewpoints, one could perform trend prediction in sales or other relevant data. Government intelligence is another application that has been considered. For example, it has been suggested that one could monitor sources for increases in hostile or negative sentiment. Opinions matter a great deal in politics, and there's something called e-rulemaking, allowing the automatic analysis of the opinions that people submit about pending policy or government regulation proposals. So if government is thinking about making a new law or policy, you can monitor what people are thinking about it before they make the law. What makes the treatment of evaluative text different from classic text mining and fact-based analysis? So fact-based analysis as opposed to subjective analysis of subjective text. Text categorization example. Traditionally, text categorization seeks to classify documents by topic. So if, there's a field called text categorization. So it's sort of like what Google does, not exactly, but you take a bunch of documents and you want to classify them into different categories. Okay, and that's a well-developed field. There can be many possible categories in that case. As few as just 2 classes or categories. That would be binary classification. But there could be many thousands of classes as well. In contrast, how does sentiment classification compare with that? Well, one difference is that you have relatively few classes, right? In just arbitrary text classification or text categorization, you could have many different classes or categories of text. But if you're talking about sentiment, usually we're talking about, for example, positive or negative, or maybe 1-star, 2-star, 3-star, 4-star, or 5-star, but that's all. So maybe just 5 categories. And these kinds of categorizations basically are the same across all the different domains of sentiment. In addition, while the different classes in topic-based categorization can be completely unrelated, so the classes that you're dividing, that you're categorizing in just regular traditional text categorization or document categorization, the sentiment labels are widely considered in previous work typically represent opposing if the task is binary classification, or ordinal numerical categories if the classification is according to a multi-point scale. So what they're talking about here is that, like we said, the categories are basically the same. You're just talking about sentiment, so it's either going to be positive or negative, or you might have, like first, second, third, fourth, fifth, and second, third, fourth, and fifth, or something like that. So an ordinal numeric categories. Okay. Regression models. So if you're talking about text categorization in general, regression models are not so useful. But in sentiment mining, regression models can be quite helpful. Regression can often be used in this scenario. Actually, a form of regression called logistic regression, or more specifically, logit regression. Multinomial logit regression is used when the dependent variable. So what is this kind of regression? So you should know that regression is a method of making a prediction. So you have the output that you're trying to predict, which we'll call the dependent variable. And when the dependent variable is nominal means categorical, or not numeric, a set of categories which cannot be ordered in any meaningful way and consists of more than 2 categories. So, for example, multinomial logit regression would be appropriate when trying to determine what factors predict which major college students choose. So you might try and determine what makes some people choose one major and what makes some people choose another major. Multinomial logit regression is appropriate in cases where the response is not ordinal in nature, as in ordered logit regression. Ordered logit regression is used in cases where the dependent variable in question consists of a set number, more than 2, of categories which can be ordered in a meaningful way. So if you're just talking about categories, that is, the dependent variable is categorical, but there's no order in terms of the categories, then you would use multinomial logic regression, but you'll use ordered logic regression if the dependent variable is categorical, but there's a possible ordering. Let's see, for example, highest degree, social class, and so on. Those are ordered. While multinomial logic is used when there is no apparent order. For example, the choice of muffins, bagels, or donuts for breakfast. It's sometimes referred to as ordinal regression. And you use it when you're doing ranking. You're ranking categories. Or rating. You also use the word rating inference. You're trying to infer the rating, trying to guess the rating, trying to predict the rating. In contrast to many topic-based multi-class classification problems, sentiment-related multi-class classification can also be naturally formulated as a regression problem because ratings are ordinal. In fact, the regression-like nature of strength of feeling, degree of positivity, and so on seems rather unique to sentiment categorization. So, regression of this sort may be quite useful in sentiment mining. Factors that make opinion mining difficult. Definition: sentiment polarity. Okay, so this is a very important word or phrase. So we give the definition here. Sentiment polarity. To classify an opinionated text as either positive or negative according to the overall sentiment expressed by the author within it. So basically it's the positive-negative nature of a sentiment. Consider the following example consisting of only one sentence by Mark Twain. Jane Austen's books madden me so that I can't conceal my frenzy from the reader. So would you say there's a positive or a negative sentiment being expressed here? The topic of the text, first of all, the topic, can we identify the topic of this sentence? So I guess it's Jane Austen or Jane Austen's books. May be identified by the frame Jane Austen or Jane Austen's books, maybe. The presence of words like madden and frenzy suggests negative sentiment. So one might think that it is an easy task and hypothesize that the polarity of opinions can generally be identified by a set of keywords. And that is what we're going to try to do. However, the results of an early study by Pang et al. On movie reviews suggest that coming up with the right set of keywords might be less trivial than one might initially think. People come up with different keywords. For example, the word still turns out to be highly correlated with positive sentiment. Now that's strange, right? That's not something that we would normally be able to know. But you can do statistical study and find that the word still turns out to be highly correlated with a positive sentiment. This is a data-driven result. It's a statistical result that comes from data. Using machine learning techniques based on unigram models, models can achieve over 80% accuracy, which is quite good, but may not be as good as typical binary classification results. Anyway, what does this mean? First of all, unigram means that what you're giving as input into your models are single words, not phrases, not two-word phrases, three-word phrases, four-word phrases, and so on, but just your single words. So that's one approach. Okay, and it's been shown that you can get up to 80% accuracy, or as good as 80% accuracy, but that may not be really as good as typical classification results where you have binary. This is binary, right? We're talking about positive, negative sentiment. But there are many other binary classification problems besides positive, negative sentiment. And maybe in many of those, accuracy is even higher than 80%. Note, unigram means selecting for entry into a machine algorithm single words instead of phrases. 2gram would mean selecting two-word phrases. Factors that make opinion mining difficult. Again, somewhat in contrast with topic-based text categorization, which is, we're not doing topic-based, right? We said to identify the topic of the sentence was not so hard, but that's not what we're interested in here. Order effects can completely overwhelm, this is just an observation, that order effects can completely overwhelm frequency effects. Consider the following excerpt, again from a movie review. Actually, I don't think we did an excerpt from a movie review yet. This film should be brilliant. It sounds like a great plot. The actors are first grade, and the supporting cast is as good as well. And the supporting cast is good as well. And Stallone is attempting to deliver a good performance. However, it can't hold up. So, is this a positive sentiment about the movie or not? As indicated by the inserted emphasis, actually I don't have it there, words that are positive in orientation dominate this excerpt, right? You can see brilliant, great, first grade, is good as well, deliver good performance, however it can't hold up. Yet the overall sentiment is negative because of the crucial last sentence. Whereas in traditional text classification, not sentiment mining, just text classification, so putting this in, classifying this as a particular type of, about a particular thing, if the document mentions cars frequently, then the document is most likely at least, or at least somewhat likely, somewhat related to cars, sorry. So we see here that order effects can overwhelm frequency effects. So something at the end may be more important than the fact that there are many other good positive words throughout the text. Okay, let's take a digression here. In fact, let's stop and make it and continue.